morning, students. Today, in the lecture 13th of Basic Electrical System course, we will discuss the series circuits in detail. We will apply the Ohm's law to determine the unknown quantities in the series circuit. We will see the applications of the series circuit in the electrical systems. So, let's start this session. A series circuit is one where there is only a single path for current to flow through multiple electrical loads. For instance, consider a string of old-fashioned Christmas lights. If one bulb goes out or gets damaged, the entire string stops working. That is because there is a single path for the current to flow, and any break stops the current flow in the circuit. The electrical load are considered for determination of the size of the wires which is to be used in the series circuit. The other components in the series circuit, such as switches and fuses, are generally not considered to be included in determination of the total load in the series circuit. The circuit must be continuous or have continuity in order the current to flow through the circuit. Now, looking above or looking in this slide, there is a sample problem or connections regarding series circuit. Here you can see the 12-volt battery is connected to 3 loads. The 3 loads are bulb number 1, bulb number 2, and bulb number 3. The bulb number 1 is having the total resistance of 1 ohm. Bulb number 2 is having the total resistance of 2 ohm, and bulb number 3 total resistance of 3 ohms. Now we have to find out the total resistance of this circuit. To determine the total resistance of this circuit, we have to simply add the resistance of these individual loads, that is the resistance of bulb 1, bulb 2, and bulb 3. So the total resistance of this circuit will be around 6 ohms. Now this 6 ohm resistance is connected to this load in series. So the current flowing we can calculate by using the Ohm's law. Current I is equal to, it is nothing but voltage divided by resistance. It gives value of 12 volt divided by 6 ohms, which is equal to 2 amperes. Now 2 amperes current will be flowing through each load. Now consider this another problem of a series circuit. In this case, we can see there are only 2 loads which are connected in the circuit. We have to find out the total resistance. The total resistance of these systems is 3 ohms and supply voltage is 12 volts. So the current flowing through the circuit we are determining by using Ohm's law, which gives the value of 4 amperes. Now 4 amperes current will be flowing through the load number 1 and load number 2, that is bulb number 1 and bulb number 2. Now here there is one more concept regarding the flow of electricity through a series circuit. So the electricity flow in a particular path is determined by the load in the particular line. If a load in a particular line is too high, few electrons are moving through them. That is, the load indicates the resistance in the systems. If there are 2 paths for the current to flow, the current will choose the path which is having the least resistance. Now, the next important concept is the Kirchhoff's voltage law. In the previous lecture, we have studied the water wheel analogy for the current flow in a particular circuit. So as the water flows through a water wheel, we can see the amount of flow remains the same, but the energy of the water reduces as the height of the water is less, as the height of the water reduces. Similarly, as the current passes through number of loads in the circuit, uh, the amount of total voltage which is supplied is reducing as it proceeds from one load to another load. Therefore, the voltage applied to a series circuit drops with each resistors. The greater the resistance, the greater the voltage drop in the circuit. Now, the Kirchhoff's law states that the voltage around any closed circuit is equal to the sum or the total of the voltage drop across the resistance. Now, looking up, looking in this slide, we can see there is a simple circuit. This circuit consists of a 12-volt battery which is connected to this bulb. Now we have to apply the Kirchhoff's law in this case. We can see here there is only one load in the circuit. So the total voltage which is supplied, that is 12 volt, is utilized across this load. Now in the other part of the circuit, if we change the voltage drop, it will be around 0 volts. So here we can see the total drop of the voltage across this load is equal to the total voltage which is supplied in the system. Now, if this fuse which is having a negligible resistance, if we check the voltage drop across the fuse, it is 0 volts. Now, take a small example to get the insight of the Kirchhoff's law. Here is a simple series circuit in which we have used the three loads of 2 ohm, 4 ohm, and 6 ohm resistance respectively. Now we have to determine what is the voltage drop across each resistors. For that, we have to use the Ohm's law. So we can see here, we have to identify what is the current flowing in this circuit. We can consider the total resistance here, which is around 2 plus 4 plus 6, that is 12 ohms. Now, this 12 volt divided by 12 ohms gives the value of 1 ampere current flowing through the series circuit. Now, again, consider the bulb number 1. For this bulb, the total current flow is 1 ampere and the total resistance is 2. So, the voltage drop here, we have to use the Ohm's law. V is equal to I multiplied by R. It gives value 2 multiplied by 1 gives value of 2 volt voltage drop across this bulb number 1. Similarly, for bulb number 2, the voltage drops is 4 ohms multiplied by 1 ampere current which is flowing through bulb number 2. It gives the value of 4 volts. Similarly, for bulb number 3, 6 ohms multiplied by 1 ampere gives the value of 6 voltage. So here the voltage drops is 2 volts, here the voltage drops is 4 volts, and here the voltage drops is 6 volts. If you sum these values, it will be equal to the supply voltage. Now consider this another problem with 12 volt battery which is supplied with the two loads which are connected in the circuit. The first load is 2 ohm and the other load is 4 ohm. We have to find out the equivalent load of the system, that is 6 ohms, and then we have to calculate what is the current flowing through it. The current comes around 2 amperes. After getting the value of current, we have to find out the individual voltage drop across each load. For the first load, it comes around 2 ohm multiplied by 2 amperes gives around 4 volts of voltage drop, and in this case it gives about 4 ohm multiplied by 2 amperes, it is around 8 volts of voltage drops. If you sum these two values, 8 plus 4, it must be 12, which is equal to the supply voltage. Now we have to see the practical applications of these voltage drops in our automobile circuits. The voltage drops are intentionally used in devices like car dash lights and fan motors. A variable resistor dims dash light by lowering the voltage to the bulbs. Similarly, fan speed in a car is controlled by adjusting resistance in the circuit, affecting the voltage and thus the motor speed. Now the testing of the voltage drops in automobile circuit, how it is beneficial for us. A voltage drop test is often more practical than resistance testing because it measures voltage loss directly during operation. For instance, testing a particularly damaged wire might show low resistance, but under current flow, it reveals voltage drop due to heat, indicating a problem in the system. So here in the today's lecture, we have studied detail of a series circuit. We have understood the use of Ohm's law to determine the unknown quantities in the series circuit. Okay. Now, this another important concept, that is the Kirchhoff's voltage law, which helps us to design and troubleshoot the electrical systems effectively, that we have studied in the today's lectures. Through the examples, we have seen how voltage, current, and resistance interact in the practical scenarios. I hope you have understood the lectures. If any doubt, please feel free to drop me any email regarding your doubts. Thank you for your attention and attending this lecture.